Welcome back. So finding the equation of the tangent and the normal is an important part of what goes on in Pearson, so we'll need to focus on this. So our function is x squared. We'll have a chain rule thrown in there somewhere at some point. So these are the couple of things that are important. X is minus 2, so s dash of x, 2x plus 1. F dash of x at x equals 2. So everywhere there's an x, we put a minus 2 in. So that's minus 4 plus 1. So at that point 2, we've got a minus 4. So we need a y value. So to put it in, we just go back to the original function and put minus 2 in, and we'll get the corresponding y value. So minus 2 squared, minus 2 minus 6. So that's 4. Minus 2 minus 6 is minus 8. Minus 8 plus 4 is minus 4. So we've got our xy pair as minus 2 minus 4. That's our xy pair. Okay? So we've got our xy. What else do we need? We've got our gradient, m. There's our m. So we can do our yt is equal to mt x at the tangent point, I guess, plus b. So we can substitute that in now. Minus 4 is equal to minus 3 times minus 2 the point, plus b. Minus times minus is a plus. So we get a plus 6 plus b. Okay, so subtract 6 both sides. Minus 10 is equal to b. So therefore yt is equal to minus 3x minus 10. That's our tangent equation. Okay, so at minus 2 minus 4, minus 2 minus 4, at this point here we've got a negative 3. Oh, it's quite steep. Okay, and that's all we know at this point. That's all we know. And we also happen to know that the equation of this line is as suggested. Negative 3. That's this one. Okay. Now what we're looking to do is to get the normal. The normal goes like that. So you can see it's going to have a different gradient and direction. And so we work that out by looking at the gradients, the tangent and the normal. That's our generic equation. So our general equation, we've already got a gradient of the tangent, which is minus 3, times the gradient of n. So divide both by minus 3, and so the normal gradient is 1/3. Well, that about fits, doesn't it? If that's negative 3, that's 1/3. So we've got our differential calculus ideas worked out fairly well. So all we need to do then is use those same things. Okay, and so yn is equal to 1/3 xn plus b. The same x and n will be used, so it's minus 4. Put in minus 2, which was our x value, plus b. So we get minus 4 equals minus 2/3 plus b. So what else have we got? We've got to add fractions. What you do to one side, you do to the other, is equal to b. And so the final thing then will be, this is on a 1. So we need to multiply it by 1 not to change it, and it'll be 3/3. So we'll get minus 12, all 3's are 12, plus 2 equals b. Minus 12 plus 2/3, same family, equals b. Minus 12 plus 2 is minus 10/3 equals b. And so our normal equation, yn, will be equal to 1/3 x minus 10/3, and that's our normal equation. That's the equation of the normal cutting across here. 10 on 3 is minus 3 1/3, so that's a good fit. Okay, for B, we'll work B out as being this one here. Okay, so this is something that you'll need to do, and we'll go through it all again, just so you get the practice. You can stop the video, work your own out, all the working's there. It's up to you to do the working out and the studying and the scrub and stuff. Alright, so for B, our function is x minus 1 all squared. Now we could do an expansion at x equals 3. I'm just thinking about the perfect square, so it's an easy one too. But this is about the practice of the chain rule, isn't it? So either way would work. So do I do the chain rule or the other? So I'm going to do the chain rule. So let u equal, we could expand this, x minus 1, or use the shortcut, x squared, x times minus 1 minus 2x plus 1. We could now go to town and do the differential on that, which would be seeming fairly easy, but just to show you, f of u now is equal to u squared, f dash of u, just to show you all the different ways we can do it, u the x, it's 1, so they're multiplied together, 2 times 1, so it seems trivial. F dash of x then is the chain rule, f dash of u times u the x, getting it complete, which is 2u times 1, which is 2 times u, which was x minus 1, which is 2x minus 2. So the gradient, now does that match? If I go here, 2x minus 2. Could have done it that way. So either way, it's important that you learn the chain rule. I value the chain rule more than I value, well, completing the square, I don't know. Maybe not. Alright, so f dash of x, either way, is 2x minus 2. We want to find that at x equals 3. So use our function notation. Everywhere there's an x, we put a 3. And so we get 6 minus 2, which is 4. So that's the gradient. It's quite steep. That's m. That's the gradient of the tangent at x equals 3. What is the gradient? What is the function value at 3? Okay, so we're going to have 3 minus 1 all squared, which is 4. So we've got an xy pair of 3 and 4. So yt is going to be equal to mt xt plus b. Yt is 4, 3 plus b. We're solving for b. 12 minus 12 minus 12. 4 minus 12 minus 8. So b is equal to minus 8. Therefore, the tangent equation is 4x minus 8. Okay, so if we do the perfect square, this thing's a perfect square at plus 1. And cuts through the axis of plus 1. It goes like that. That's our perfect square. And at x equals 3, which is way up here somewhere, we've got a very steep gradient that goes like this. Now at that same point now, we're going to work out the normal. It has a gradient and this has an equation. Okay, So geometric interpretation will just continue to help you. So please keep that in mind. All right, so for yn, we've got the same pair, which were 3 and 4. So 4 is equal to, no, what's the gradient? Okay, so our gradient we worked out was 4. So 4 times the gradient of the normal is equal to -1. So the gradient of the normal is -1/4. That's that equation, isn't it? MTMN is equal to -1. Okay, so just drop the 4 in there. So we also coincidentally happen to have an xy pair of 3 and 4. So 4 is equal to -1/4 times x, which was 3, plus b, because we're working out b. So summing all in to get b. Okay, so that's 4 minus 3/4 plus b. So add 3/4, never goes away. You got to deal with fractions. So 4 plus 3/4 is 4 3/4. So that's kind of a bit of a blessing in disguise, but you know me, I want to do it like this. So we've got 4 times 4, 16 over 4 plus 3 over 4 is 16 plus 3 over 4, which is equal to b. 16, 17, 18, 19, 19 on 4 is equal to b. So yn is -1/4 x plus 19. And if we think about that line there, that's about right, because 19 would definitely be up here somewhere. Well, it's 4, isn't it? 4 4s are 16, so that's 4 3/4. So that's a good fit. So we've pretty much nailed both of those, okay? It's just a process that you need to go through. You need to do your derivative. You need to understand the geometric interpretation of your sketching. Work your little equations until you get them all out, okay? All right, let's keep going with it because it's what we've got to do. It's why we're here. So let's keep going for that. So for C, our function is 1 on x. So it's a composite function. Don't know much about it, so this is ideal for working out what's happening using calculus, because I've got no idea what 1 on x plus the square root of x is. I can guess, but I'm not going to. The other thing, I'd like to know the y value, so I'll just work out the y value. So it'll be 1 over 4 plus the square root of 4, which will be 1/4 plus 2, which will be 2 1/4, which will be 2 4s are 8 plus 1, 9 on 4. So that's our y value, that's our x value. So we've got an xy pair of 4 and 9 on 4. Now 9 on 4 is 3 on 2. So I might change that to 3 on 2. 3 on 2, okay? Alright, so now we've got now we haven't done the derivative yet. Bit of pre-work. X to the -1 plus x to the half. Oh, okay. Therefore, f derivative is going to be equal to -1 x to the -1 minus 1 is -2 plus a half x -1 never goes away. It's going to be minus a half, we'll give it that. So this is -1 over x squared. That is minus a half. X to the minus a half is going to be plus 1 over 2 root x. So that's our derivative. So our derivative at 4 is going to be equal to plus, so putting the numbers in, 1 over 16 plus 1 over 4, not the same family, So minus 1 plus 4 over 16 is 3 over 16. So it's a very slight gradient. Very slight gradient. 3 over 16. Okay. So our tangent equation, which is 3 on 2 and 4, will be 3 on 2 is equal to 3/16 of 4 plus b. Subbing in for b, x, y, m, t. Okay, so 4 is going to cancel once. So we'll get 3 on 2 is equal to 3/4 plus b. Subtract 3/4, subtract 3/4. If you can't do fractions, you're in a bit of trouble. So double up. So 6 minus 3 all over 4 is b, which is also equal to 3/4. So yt is equal to 3/16 x plus 3 on 4. Would make that bigger, but that's it. So wherever that point is, whatever that looks like, that's how it's presenting. So all we got was 1.5 and 4. And at that point, we had a very lazy positive 1.5 cutting at 3/4. So that's our yt. That's our yt. Now we're going to find the normal. Now that's not knowing anything else about the geometry of that summed functions. It's just learning about that one point. So again, 3/16 m normal is equal to -1. So times by 16 divided by 3. So mn equals minus 16 on 3. That's our gradient for this one. Minus 16 on 3. So then we've got the same issue. We've got to work out y normal, 3 on 2. The gradient is minus 16 on 3. The x value is 4. There's our b. Okay, so we've got to put that over the other side. So b is equal to 3 on 2 plus 16 4s, 64 on 3. So this is annoying because it's a genuine 6. What you do to one side, you do to the other. 128. So 128 and 9 is 138, it's 137. Over 6, 6 goes into 13. That's 12, but it doesn't go into 17, so b is this. So yn, this one here, yn is equal to minus 16 on 3 x plus 137 over 6. So there are two equations. Oops, I didn't put that one up. That one's there. Okay, that's this one over here. Alright, so you can see how it's working as a pattern. You've got to progress this for Pearson. To get through this subject, you need to be able to do this. Whether you get questions about this or not is irrelevant in Maths 1, because if Maths 1 assumes that you know how to do this, this is important, okay? Alright, I'll do D and then we'll call this video, and then we'll have a look at some chain rules afterwards. Okay, so we're getting to D now. So the function is a cubic. Now a cubic will have a lovely shape. You can check that in Wolfram, just put that in please to satisfy yourself. X is -1, so we can get a y value and just put that in, -1 cubed. It's an odd, so the minus stays. -1 squared, it's an even, so the minus disappears for that, but there's already a minus outside, so don't get confused by that. So -1 cubed is -1. -1 squared is +1, but there's a -1, and then -5, so it's -5, -6, -7. So the y value pair is -1, -7. Okay, now the derivative is equal to 3x squared minus 2x. That's it. The derivative at x equals -1. Everywhere there's an x, you put a -1. Put in brackets. -1 squared is a positive, so that's 3. Minus times a minus is a plus, so that's 2. So we've got a gradient of 5. That's our MT. Okay, a gradient 5. So at these points here, MT is 5. Alright, actually it'd be nice to have a look at that cubic, just to show you, but we're going to finish this off and I'll see if I can get it without much help. Alright, so the next thing we've got is YT, so -7 is equal to 5 times -1 plus B. Okay, so that's -5, so adding to both sides, +5 plus 5, -7 plus 5 is 2, so therefore B is equal to 2. So our tangent equation is 5x plus 2. Okay, our M5 Mn, so therefore Mn is equal to -1/5, and that'll be interesting. And then our normal, what do we got to put in this thing? -7 is equal to -1/5 times -1 plus B. So that's a plus. It's a fifth. So we're going to add a fifth to both sides. So we take a fifth off 7. -7/1 plus a fifth equals B. So that's 5 and that's 5. So now we're -35 plus 1. -34/5 is equal to B. So our normal equation is -1/5 x minus 34 on 5. So that's our normal equation. Now just thinking about this equation, I'm going to do now that you don't need to do this. This is what you'll learn in later on. We might do a bit of curve sketching. But for now, I'm just going to take the second derivative. And I'm going to go back to the first derivative, which was where? Here. So 2 3s are 6x minus 2. 6x minus 2. The other thing I can do is I can set f dash of x to 0. Solve. We know that's what that means. So 3x squared minus 2x equals 0. X outside of 3x minus 2. So therefore x is 0. Or that 3x has got to be 2. So in order for 3x to equal 2, x has got to be 2/3. Okay, so that's the point. They're those points. So they're points of inflection because I did analysis on this. So they're points, they're turning points or stationary points, we'll call them. Now this one here, where's my x value? My x value, if I solve this, solve. One third. Now if I put into my second derivative, 0, that's a minus, so it's a sad face, so that 0 has that. If double dash, it doesn't matter if you don't know what I'm doing here, I'm doing adjacent thing. 6 2/3 minus 2. 2 2s are 4. 4 minus 2 is 2. So that's plus, so that's a happy face. Alright, so I've probably got enough to sketch it. So if I go and do my cheek, I've got 0 and 2/3. Somewhere on those are a happy face and a smiley face. And I've also got a point of transition. This is called inflection at 1/3. So that's 2/3. So 1/3 would be 3/3 would be there. 2/3, 1/3. So there's an inflection here, or a change in concavity. So I just want to get some values. The function value when x is 0 is minus 5. So this is when x is 0, the function value is minus 5. Oh, well, that makes sense. So that minus 5 is this. I think it's coming like this. Now the 2/3, what's the 2/3? 2/3. I'd like to know the y value. Two 4 2s are 8. 27. 2 2s are 4. 9 minus 5. So it's a lot of stuff, isn't it? 8 minus 3 is 12. That's 1's got to become 27 5s. 5, so 35. 1335 minus all over 27 minus 135 is minus 147 plus 1 is 139 over 27. Now 27, 30, 60, 90, 100, 30, 60, 90, 100, one more. It's 5 and a bit. So it's at 1/3, it's minus. I better just check that with a calculator. 139 divided by 27, 5.1. That's a little bit more than 5.1. It's here. And what's the 2/3 value? I just did that. So that's that one. Just a little bit more. And what's the 1/3 value? Did I do that before? What's the 1/3 value? We get 1 on 27 minus 1 on 9 minus 5. I'll just do it that way, a bit lousy. Minus 1 divided by 5.07. So it's a little bit less. A little bit less, so it's a little bit less. I've got to look at the single diagram. Ooh, the single derivative. and test a couple of values. So minus values would be positives. So 3, say if I did minus 1, 3 minus 1 would be 0. Yeah, I've kind of thrown a little bit here and I don't know why. This video is going on too long, Jason. Okay, so what are you doing, mate? Check a couple of values. Just check minus 1. Check minus 1. Minus 1, minus 1, minus 5. Minus 7. Yeah, so minus 1 would be minus 7 down here, so that's a good fit. So it's increasing. And then it's going to come to here. It's going to have this down. But that value, 2/3, is too far. Come down like this. Slide them out. Then it's going to come back up. Like that. That's something like that. So this is the upside down face, this one. This is the smiley face, this one. And this is the point of inflection. This is where it's changing from going down to up. So that's the point of inflection. So I didn't solve the equation for its intercepts. It's just that one thing. So, oh well, let's find out. This is the real test, isn't it? X cubed minus x squared. Don't want to differentiate it. X cubed minus x squared minus 5. Let's see what you look like. No. Y equals, treat it like a function. What are you doing? X squared. Goodness gracious, I'll get it right one day, won't I? Ah, beautiful. Look at that. Okay, I'm feeling much better about that. Alright, so there's our little swoop. There's our scale's changed, obviously, but there's our lovely little swoop with its points. So without knowing the actual curve, I was able to use calculus to give a bit of a sketch, which is what this is all about. Alright, I'll see you for the next one.